All right, it's time to talk a little bit about relations and functions as far as the math world goes. So, here is a little bit of an intro to relations and functions, and what do we think the word relations means in mathematics. Very similarly to a relationship in regular world, a relation is a set of pairs of an input and an output value. So a relationship between two people is the set of people and the different things that are happening between them. A relation in math is essentially the same thing. It's a set of pairs. So they are a bunch of points, they are inputs and outputs. You can represent relations in a ton of different ways. I'm going to show you a bunch of those in just a minute. But over here in this little box, it does tell you you can represent relations in ordered pairs, in an input-output table. Some of you guys call those T-charts, in a mapping diagram, in points on a coordinate plane, in equations, or just in words and sentences. Back in the beginning of the year, we talked about translating math from an expression or from a point into words and sentences. So this is another time where we will be doing just that. These are a couple of the ways that you can represent a relation in math. We just talked about, but these times they have little pictures for you to kind of go along with. This is not obviously all of them. You did see the list, but this is some of the ways that it can be represented to you. You can see the ordered pairs are something you are relatively familiar with. Ordered pairs are just points on a coordinate plane. Your input, output, or your T-chart, the coordinate plane itself in the picture, each of those points and those combined points are part of a relation. And a mapping diagram is the bottom left one over here. It is the one you're probably the least familiar with. They can be in ovals like this. The numbers can be kind of in a strange amoeba-like squiggly shape. Sometimes you will see them in boxes. Most often you will see them like this in an oval. And the lines that you're seeing in between that connect, in this case, the 3 to the 6, the 5 to the 10, the 7 to the 14, connects the input. If I were to put 3 into this relation, when I put it through the relation machine, the number that's going to come out, the output is a 6. When I put in 7, the number that's going to come out is 14. When I put in 5, the number that's going to come out is 10. You might be able to know for yourself what's happening here, that when I put the input in, what I'm getting back out. You might have figured out that pattern already for that one, which is good. And just a quick reminder as far as reminders go, inputs refer to your x values, which, don't forget, in a point, the x comes first, and your output refers to your y value. So if you're seeing a list of points, you are seeing input and then seeing the output. So if these are what relations are, what is a function? What is a function in math? A function is something very specific. A function is a kind of relation. It's a very special kind of relation where every input has exactly one output. So that means when I put in a number, I can only get back one result. It's a very specific, very close-knit kind of relation. So I can put in something, I'm going to put in one input, just one number, and I'm going to get out only one response to that number. So you can see here all of these numbers. If I put in a 1, all I get out is a 4. If I put in a 2, all I get out is a 7. If I put in a 3, all I get out is an 8. If I put in a 4, all I get out is a negative 2. These are all examples of functions. That one that I showed you before, the 3, 5, 7, 6, 10, 14. Those are all functions. They are only giving you one output for every input. There's only one y for every x. What that looks like when you're drawing it happens a bit over here. It tells you a very important characteristic, that if you look at a graph of a function and you can draw a vertical line through it, and that line does not touch more than once, it's a function. If it touches your function or touches your picture more than once, it's not a function. We'll see a couple examples of that in just a little bit in some pictures. And the key thing here, we're going to talk about this more in a few days once you get used to it, but the key here is that functions are written as f of x, where x is your input, and that f of x is just a fancy way to say y. You guys have seen some things we would write equations. They would say y equals 2x plus 4. Now, the function way of writing that is just like this. F of x equals 2x plus 4. You don't have to do anything with that f. F of x is just another way to say y. It's one of y's nicknames. Some of you have many a nickname. F of x is just a nickname of y. And this is a bunch of examples of relations. Not all of them are functions. I'm going to kind of go through really quick and point out a few that are very much not going to be functions. This piece here, this mapping diagram, is not a function. If you look very closely, when you put in the input of 0, it's telling you that you're going to get out both 2 and you're going to get out 3. Well, we said in a function you can only get out one thing. So that is not going to be a function. Let's put a big red X for not a function. Over here, we see a picture. It's a relation. It's a graph. If I were to draw that, and I were to draw vertical lines, I'm going to draw a bunch of vertical lines. If I draw a vertical line through that graph, it's going to touch in more than one place. We cannot have that touch in more than one place, so that makes it not a function. You can see that same thing happens down here. If I were to draw vertical lines through each of these points, this one has a point here and here, meaning it touched more than one point at a time, not a function. There is one other piece here that is definitely not a function, and I'm not going to tell you which one it is. You're going to tell me which of these pieces is not a function. Going over this very quickly, we're going to talk about this in depth tomorrow, but today is the day just to kind of remind you that these words exist. You have heard of domain and range at some point in your mathematical career before today, but I'm just here to gently remind you that it does exist, and these words here are all synonyms of each other. That's going to help you out a lot. Your domain and range are just math words for input and output, or X and Y. Your domain is your input, and your range is your output. All of these things come in alphabetical order, which is the quick way for you, hopefully, to remember. Domain starts with a D, which also input starts with an I. Those are the early ones. And X, all alphabetically come before their counterparts. So that's how you can kind of know that they group together. They do combine like that. Just a couple examples of the vertical line test as well. The orange line is a vertical line drawn through each of these things, and you can see the ones that say not a function down at the bottom, down here. That vertical line does touch in more than one place. I can do that moving here for you as well. I have a red vertical line that if I were to drag, oops, there we go. If I were to drag this red vertical line across my function, you will see that it only touches the green at one point at a time. So that is very much a function. However, this one over here that it tells us is not a function, immediately when we start is touching 2 points on the green the whole time, telling us very quickly that is not a function. And I just want to show you 2 more mapping diagrams really quick. We have a mapping diagram here, wanting to decide if this is a function or not, so we can trace out each of the inputs to outputs to find out. So the 8 is going to the -1. So far, so good. The 9 goes only to this -3. This 10 seems to only go to the -1. And the 13 seems to only go to the 5. So that is beautiful. None of the inputs go to more than one output. So that is a function. And then we have one more. Like I said, they can look a little amoeba-ish. Is this a function? Why or why not? Let me know.